Today's lesson is exponential functions, and we are going to write equations from a graph without a calculator. Okay, what's our learning objective for today? I can write the equation of an exponential function from the graph by determining the transformations from the parent function and writing a generic equation, substituting a point from the graph to solve for the base, and writing the final equation. So let's take a minute here and decide where we are on that learning spectrum from novice to expert. Okay, yesterday we talked about exponential functions are transcendental, which means they are non-algebraic. And that means that the variable is the exponent. And I have two different cases that I'm talking about right now where my base is greater than 0, not equal 1, and when the base is greater than 1, I call that exponential growth. And when my base is between 0 and 1, I call that an exponential decay. Okay, we covered some key aspects of exponential growth and decay. We said the domain is the set of all real numbers. The range is y is greater than 0. That the asymptote is at y equals 0. And an asymptote is a line that we approach, but we never go across. There are no x-intercepts. My y-intercept is at 0, 1. And the exponential growth is an increasing function, which means if I had a tangent line to the graph, I would have a positive slope. And the exponential decay is a decreasing function. And that means if I had a tangent line, to the graph, I would have a negative slope. And the function, both the exponential growth and the exponential decay are both 1 to 1, meaning that my function and its inverse is also a function, which means I pass the horizontal line and vertical line tests. Okay, I have two examples. So we have our transformations from yesterday, and the steps for writing the general equation from the graph. We are going to locate the horizontal asymptote. This is my D transformation. Then I'm going to find the point that's 1 unit above this asymptote or below. And this is going to be my 0, 1, but it's transformed. So the x-coordinate of this point is going to be my C transformation. So if I went to the left, or if I shift to the right, it's going to be x minus c, and if I shift to the left, it's x plus c. I need to make sure I add a negative sign for a reflection if that's appropriate. And I'm going to use another point on the crosshairs to substitute into my equation and solve for x and y. And I'm doing this similar to what we did with polynomials when I was solving for the leading coefficient. Next, I'm going to solve for the base, and then I'm going to rewrite the equation with the base and all the transformations. Okay, so what does that look like? So I'm looking at my graph here. First thing I want to do is locate the asymptote. So I see the asymptote is right here at y equals 2. So I know my asymptote is at y equals 2, and this is my D transformation. So now I'm looking for one box above or below the asymptote, and a point on the crosshair. So I have a point right here. So this point is -6, 3. So the x coordinate, this is my c transformation. So c equals -6. So to write that as a factor, that is x plus 6. And then I want any other point that's on the crosshairs. So I'm looking for a point on the crosshair. So I see this point right here, which is -5, 7. So I can use any other point. And on this particular graph, that's the only one I really have as a choice. So I know I have a point for -6, 3, where this -6 is my c transformation. And then the other point I'm going to use is -5, 7. And this is the point I'm going to use to substitute to find the base. All right, so let's write our general equation first. So I'm going to write this as f of x equals, I don't know what my base is, so I'm going to just call it base. And I said I have a vertical shift left. So I write that as x plus 6. And then I know I have this is a horizontal shift left 6. And then I have a vertical shift up 2. So this is my d transformation, so plus 2. So this is my general equation. Now I want to substitute in -5, 7 for x and y. So y is 7 equals the base, and x is -5 plus 6 plus 2. So now I'm going to simplify, and I have 7 equals the base to the first power plus 2. So I'm going to subtract 2 from both sides, and I get the 5. That 5 is equal to the base to the first power. So now I'm going to rewrite my original equation with 5 as the base. So I know f of x equals 5 raised to the power x plus 6 plus d, which is 2. Okay, so first I find the asymptote. Then I look for the point that is 1 unit above the asymptote. That's where this x coordinate is the c transformation. And then I find another point anywhere that's on the crosshairs, and I substitute that in to find the base. And then I rewrite the general equation, knowing the base. All right, I'll let you have a chance. Okay, so I want you to pause the video and take a minute trying to do this and see what you get, and then come back and check. Okay, so the first place that I start is locating the asymptote. So I see the asymptote right here at y equals -5. So I know this is, so I know d is -5. Okay, so now I'm looking for the point that is 1 unit above. So I see that's this point right here, which is 4, 4. So I know C is 4. This is my C value. So C equals 4. So writing that, I write that as x minus 4 as a factor. And then I want to find any other point that's actually on the crosshairs. So I could use this point right here is right on the crosshairs, which is 3, negative 2. Or I could use this point here, just right on the crosshair. So I can use more than one point. So I'm going to use this one here. So 2, 4. But anyone that's right on the crosshairs is okay to use. So I'm going to write my general equation first. So this is f of x equals my base. And I'm going to raise it to my horizontal shift factor, which is x minus 4. And then my vertical shift is my asymptote, which is minus 5. So then I'm going to use my point 2, 4. This is what I'm going to use to substitute. So I'm going to substitute in 4 for y and 2 for x. So we got 2 minus 4 minus 5. So I'm going to add 5 to both sides first. So I get 9 equals my base raised to the negative 2 power. So when I have a negative power, that means I need to change it from the numerator to the denominator, or vice versa, wherever the negative is. So I'm going to rewrite this as 9 equals 1 over the base squared. Now I know 9 and the base squared are in logically equivalent places, so I am just going to trade places. So I'm going to say the base squared equals 1 over 9. Now I can solve for the base. So to undo the squaring, I'm going to take the square root. When I take the square root of one side, I have to do it on the other side to keep my equation equal. So my base is, the square root of 1 over 9 is 1/3. So now I'm going to rewrite my equation. My general equation, so I'm going to substitute this in. This is f of x equals my base, which is 1/3, raised to the power x minus 4, plus or minus 5. How did you do?